Hi guys, welcome to my video. So today I'm going to discuss the catalytic cycle for Cytochrome P-450. So first of all, to know this we need to know what does Cytochrome P-450 does. So Cytochrome P-450 is helps in the incorporation of one molecular oxygen atom into the substrate. That means it adds one molecular oxygen atom into whatever is the substrate taken. For example, this is our RH substrate. This is oxygen plus 2H plus 2 electrons in the presence of cytochrome P450 gives ROH plus water. So here cytochrome P50 plays the role of, here RH was there and here we can see ROH. So it has incorporated one oxygen molecule in the substrate. So here as we can see, this is a cytochrome P450 structure. So up is the water and here down we can see is the, on the 6th coordination side is the sulfur atom of the cysteine. So here we can see that iron is in +3 oxidation state and it has 6 coordination sides, so it is a low spin complex. So over here we can see that we have added the RH. Okay, that is our, we can say, any molecule, and here what happens is this water is loosely bound to the iron atom. So what happens is this water leaves from here and this RH or our substrate does not bind to iron directly. It remains in the cavity because here the RH, it does not have any lone pair to bind with this iron or metal center. So there is no present on this RH. There is no lone pair present on this RH. So it will not directly bind. Okay, so what happens is it will just stay in a cavity here, and from here the water will leave since water is loosely bounded to the metal center. So as you can see here, the RH, it has no lone pair here. Okay, and it cannot bound through this is the sigma bond here between R and H. So this RH, the sigma bond cannot bound to the metal center, so that is why it will just be present in the cavity of this molecule. So now after the water leaves, we can see that the iron has become 5 coordinated system, right? First it was over here, it was a 6 coordinated system as we can see, but over here now it has become a 5 coordinated system, and here our RH is present in the cavity. I've just shown it at the side over here. So here what is the change that took place is, here the oxidation state of iron is 3. Here, even here it will remain 3, because why? The water that is left, that is a neutral molecule, so that will not affect the oxidation state of the iron atom. But what has changed is the coordination site. In this structure the iron was in 6 coordination state, but now here it is in 5 coordination state. So here when it is in 5 coordination state, so what will happen is the complex will change to high spin. Here it was low spin in 6 coordination sites, but here it will change to a high spin complex. Now in this structure also we can see that iron is out of the porphyrin plane. Why? Here we can see that here it is in the plane, right? Iron is the plane of, here this is our porphyrin ring that I have shown. So here we can see that iron is out of this porphyrin plane. Now why is it out? Is because it is in high spin, T2G3 Eg2, right? So when our electrons are entering in Eg, what happens is the size of the complex will increase, whereas here there is no electrons in Eg, it is low spin, all electrons are there in T2G. So that's why we can see iron is here is in the porphyrin plane, but here it is not in the porphyrin plane. So now what happened is, now we want to bind oxygen to this iron, but here iron is in +3 oxidation state. Now for iron, for oxygen to bind, it has to go to +2 oxidation state. Okay, oxygen will not bind to iron in +3 oxidation state. So what we are doing is we are adding an electron. From where we are taking this electron? From over here. Here I have already mentioned the general form. We have taken 2 electrons over here. So 1 electron I am adding here. What we are doing is nothing but reduction. Okay, so 1 electron I am adding here. So now what will happen after addition of 1 electron? Fe3 plus will go to Fe2 plus state, and now still it will be high spin only because it is 5 coordinated system. This is, if we know, it is same like deoxyhemoglobin, only the difference in hemoglobin B is imidazole from histidine is in heme B, whereas here we have the cysteine group. Okay, so now we have the iron here in +2 oxidation state. So now here we have after the iron is in +2 oxidation state, now we know that it can bind with the oxygen atom. So here we are introducing O2, but now see O2, that would be in the superoxide form, but we are introducing it with 1 more electron to make it in the peroxide form, as we can see here. See, O2 minus plus 1 electron will give O2 2 minus. So here it will be single bond in peroxide, but whereas in superoxide the bond order would be, this would be the superoxide form, it would be 1.5. Now we need it here in the peroxide form. Okay, so that we get this form of structure. So here we have introduced it in the peroxide form, and we can see that O minus, here 1 more charge is there, but since it is forming bond we are not able to see that. So here we are having it in the O minus form. So now here what we have done is iron will be in +3 after the oxygen has binded, and now it will be, it has 6 coordination sites, right? So it would be a low spin and there would be 6 coordination sites. So now what we are doing is, here I am having a O minus, so I'm adding here a H plus. So this H plus will go and bind with this O minus, and here this RH is still present in the cavity. So here what happens is, we can see the H has come and bound to this minus charge of the oxygen, and this is our molecule. Here still iron is in +3 oxidation state and it is a low spin complex. So now what will happen here is, there will be a heterolytic cleavage taking place here. So heterolytic cleavage, what will happen, this entire thing will move, electrons will move to here and heterolytic cleavage take place. Now after the heterolytic cleavage, this oxygen, okay, this oxygen will still remain here. Now that will form a double bond with iron, as we can see here. Oxygen is double bondedly with binding with the iron center, and here we will see that radical cation intermediate is formed. Okay, and here Fe is in +4 oxidation state and it is still low spin because 6 coordination sites are there still. Okay, now here it is 1 electron there is which is used for oxidation of iron, and 1 electron is oxidizing the porphyrin ring. That's why we are getting this radical cation intermediate. Now what happens is, now this oxygen, this molecule, this radical cation intermediate gives this oxygen to this RH. So now here we will get this ROH, and this water will come and bind here. Now this is the first step that we got. The same, the radical cation intermediate provides the oxygen to RH. Now here again iron will go in +3 oxidation state and it will give low spin. So yes, thank you for watching this video, and please subscribe to my channel and like and share the video.